Hello students, in today's class I will explain intensity distribution curve. Write down intensity distribution curve. So let us consider in y-axis intensity I, and in this x-axis let us consider the phase angle or phase difference between two waves, interfering waves, that is phi. And if we draw the intensity distribution curve, means you will observe in this way. So this is intensity maximum, and next that is bright fringe, and next intensity minimum, and then intensity becomes maximum. Here also you will observe the same. So this is the intensity distribution curve for interference. See here. So here we can say this is the maximum value of intensity, that is I maximum, and here this is the minimum value of intensity, that I will represent it as I minimum. So when we will have intensity maximum and intensity minimum is, you know that, so these are the two slits. Here there is a screen, this is the perpendicular bisector like you consider, and this is here you will get bright fringe, that is called central maxima. This is what? Central maxima, bright fringe. So their phase difference is 0. This phi value is 0. And next you will observe a dark fringe. In this dark fringe, here this is here the phi value is pi. So you have studied a condition for constructive and destructive interference. Even multiples of pi. Even multiples of pi means again you will get 2 pi, and again you will get 4 pi. Even multiples of pi, intensity is maximum. Odd multiples of pi, pi, 2 pi, 3 pi, the intensity is minimum. And here also, so this is in down direction, right? Hence I can able to write minus pi, here minus 2 pi, and here minus 3 pi, and here minus 4 pi. And remember, all bright fringe have same intensity, equal in width, and all dark fringe intensity is 0. Here I minimum value is 0. That is, you know that intensity maximum formula A1 plus A2 whole square, isn't it? Here if A1 is equals to A2, then you can write it as that means A plus A, 2A, that means you will get 4A square. This is intensity maximum value, 4A square. And then if I want to find the average intensity, I average intensity means what I will do? Intensity maximum plus intensity minimum by 2. That is, intensity maximum is 4A square, intensity minimum is 0 by 2, then you will get average intensity is 2A square. So remember this graph, that is intensity distribution curve in interference. And also I said, remember that the fringes width, all fringes width, bright and dark fringes width is same. Bright fringe intensity, that is maximum. All bright fringe intensity also same, and all dark fringe intensity is 0. So after understanding that intensity distribution curve in interference, next note down some points. That is, if two waves from incoherent sources superimpose at point P or at P point, then the resultant intensity is given by, this is the resultant intensity I, this is equals to, this is the intensity of first wave plus this is the intensity of second wave. Okay, this is for incoherent sources. From two incoherent sources, the light waves superimpose at point P, then the resultant intensity is I1 plus I2. And next point, remember, if n number of waves having intensity I naught and superimpose at point P, then the resultant intensity is given by, so this is the resultant intensity. Each intensity, that means each wave intensity is I naught plus I naught up to n terms, then I can able to write this is equals to n I naught. So these 2 points for incoherent sources. Direct formula is given. So while solving problems in competitive exams, so remember, for incoherent sources, here 2 waves means I1 plus I2, and n waves superimposing at point P means n into I naught. And then if two waves from coherent sources superimpose at point P, then the resultant intensity, or a resultant, you can consider here resultant maximum intensity. Already you came to know that I maximum value is equals to root over I1 plus root over I2 whole square. This is for two waves from coherent sources. Then I maximum is equals to root over I1 plus root over I2 whole square. And if n number of waves having intensity I naught, so previously this is the condition for incoherent source, right? N number of waves having intensity I naught from previous, that is incoherent. From now here you consider coherent sources, coherent sources, and superimpose at point P, then the resultant intensity is given as, here resultant intensity is root over I naught plus root over I naught plus up to n terms whole square. Then you will get the final expression as n square I naught. So this is for coherent sources. The resultant you can consider here maximum intensity, that is I max, that you can consider due to number of waves, n square I naught. These formulas remember. Next, today I'll explain some concepts useful for competitive exam only. So next concept, this is also for competitive exam. Write the heading highest order of maximas and highest order of maximas and minimas. Maximum is bright fringe, minimum is dark fringe. So we will find how many number of bright fringe will form, how many number of dark fringe will form. So for that, you know that first approximation we have taken according to first approximation, D is lesser than capital D. Only if this condition satisfies, then the path difference delta x we can consider it as D sin theta. So this highest order of maximas and minimas we will consider only one approximation, first approximation only. In that case we will find how many number of dark fringe will form, how many number of bright fringe will form. So here first I will derive the condition for maximas. For maximas means bright fringe, this path difference d sin theta should be equals to n lambda, isn't it? The path difference should be equals to n lambda. This is for condition for maximas or bright fringe. Then here nth order, highest order bright fringe we have to find. So when this value become maximum means when sin theta becomes 1. Sin theta maximum value is 1, right? When sin theta becomes 1 or sin theta becomes maximum, we can consider n as also maximum. If sin theta is maximum means we can consider it as n as maximum. Then in the place of n, I can able to write n maxima is equals to d by lambda. So this is the formula to find the nth order bright fringe. That means let us consider this is the screen, these are the two slits, this is a central, here a central bright fringe will form, and suppose after substituting the value if we got this answer as 3, then what is the meaning? So 1, 2, 3, like that 3 bright fringe will form. Understood? If I got the value 3 means this is the meaning, from the central bright fringe 1, 2, 3 bright fringe will form. Similarly below also 3 fringes will form, right? Okay, below also 3 fringes form, totally 1, 2, 3, 4, 5, 6 fringes. Then What about the central bright fringe? Always center bright fringe only will form. So how many number of bright fringe formed here? Total 7. So this will give the nth order of the bright fringe. So to find total number of bright fringes, how to consider this expression means 2n maxima plus 1. Okay, so above 3, below 3, that is nothing but 2n maxima plus central bright fringe, that also we have to consider. So total number of bright fringe if we want to find, if we want to find means we have to apply 2n maxima plus 1. Similarly, next we will see the condition for minimas. Okay. For minimas, the path difference d sin theta is equals to, for dark fringes 2n minus 1 lambda by 2. Okay, this is the condition for dark fringes. Bright fringes n lambda, dark fringes 2n minus 1 lambda by 2. Here maximum dark fringes. Okay, again this value become maximum, right? When this value become maximum means when sin theta becomes 1. If you consider sin theta maximum value 1, then I can able to write here 2n minus 1 is equals to 2 into d by lambda, or 2n is equals to 2d by lambda plus 1, or n is equals to, here if you bring to this side, that becomes d by lambda plus 1 by 2. So here you can write minimas. Okay, nth order minimas. There nth order maximas. Nth order minima formula becomes d by lambda plus 1 by 2. So that means again, so this is always center maxima will form. So after that dark fringe d1, next bright, next dark d2, next bright, next dark d3. Like that, if I substitute, after substituting the value, if I found the value is 3, this is the meaning. Above central fringe 3 dark fringes will form. Similarly below also 3 dark fringes will form. So total how many dark fringes? 6. Then to find total number of dark fringes or minimas, total number of dark fringes, just we have to consider 2n minima. Okay, 2n minima only, not plus 1. Why? Because previously we have taken plus 1. Why? Because center bright fringe is forming. Now also center bright fringe will form. So we cannot add plus 1. Just the formula is, here 3 means downside also 3, here 2 means downside also 2. Like that, n minima we have to multiply by 2. Then it will give total number of dark fringes. I hope you understood this concept. In PU it will not ask any questions. For competitive exam, note down. So based on this problem, I will explain, listen. In YDSC experiment, Young's double slit experiment, let us take capital D 1 meter, distance between source and screen, slits and screen. Small d, let us take 1 millimeter, and wavelength, let us take half millimeter. Okay, so we have to find the position of first maxima from central maxima. This is the question. All values are given. You have to find position of first maxima from central maxima. So previously also some example problems I explained. I hope you also practiced. Then in that problem, the normally wavelength will given like 650 nanometer, 500 nanometer. In nanometer wise, they will give that wavelength. And also this D and this small d, as usual, they will give 0.5 millimeter, 1 millimeter, 0.28 millimeter. In millimeter wise only they will give. This will give in meters, 1 meters, isn't it? But wavelength, previous problem you have solved in nanometer, but in this problem I took the wavelength in millimeter. What difference it will make? So understand carefully. What is our first approximation? First approximation is small d is lesser than capital D. So small d is 1 millimeter, capital D is 1 meter. Definitely here capital D is greater than small d. First approximation is valid. Then path difference we can take d sin theta, isn't it? Then what is the second approximation? Second approximation is x is smaller than capital D, right? So x is smaller than capital D or d is lesser than capital D means here you can consider this formula x equals n lambda capital D divided by small d. So here also from this expression, if these two satisfied means, then lambda also should be smaller than small d. Remember, in every question you have to check whether the lambda is smaller than small d or not. So in this case, in the previous cases, nanometer and millimeters, definitely lambda is smaller than small d. But in this problem, lambda is half millimeter, small d is 1 millimeter. It is not too much smaller. Then second approximation, in this problem only, it is not valid. It is not valid means then our path difference is not delta x is equals to 2xd divided by capital, that means xd divided by capital D. Our path difference is only d sin theta. So I hope you understood these concepts. Previously, no problem. In everywhere, lambda is very, very smaller than small d. Then two approximations will valid. But in this problem, second approximation is not valid. In that case, lambda is not smaller than small d. Then we have to take the path difference, delta x is equals to d sin theta only. Then this d sin theta should be equals to what they are asking, first maxima from central maxima, first maxima's condition, d sin theta is equals to n lambda. So d sin theta is equals to n lambda means here first they are asking, right, n value becomes 1, n value becomes 1 means d sin theta is equals to lambda. Then what is sin theta value? Sin theta is equals to lambda by d. This equals half millimeter into 1 millimeter. Millimeter will get cancelled off. And here sin 1 by 2 means theta is equals to 30 degree. Right. So we got theta value. Theta is equals to 30 degree. Then what does it mean? This is the screen and this is central axis. These are the two slits. This is midpoint of two slits. So this is central maxima and this is first maxima, and first maxima angular position is given that theta value that is equals to 30 degree. It is at 30 degree from this central maxima. This is linear position, this is angular position. Then so we have to find the linear distance, right? X value we have to find. This is capital D. Now so we know capital D, this is 1 meter and theta value is 30 degree. Directly we have to find opposite side, right? Now we can able to apply tan 30, tan theta is equals to x by d. Then x is equals to d tan 30. Then x is equals to d tan 30 means 1 by root 3. D value is also 1 by root 3 meters. If second condition is not valid, lambda is not very small comparing to small d, then in this way we have to solve problem. But PUC, don't worry, this type of problem they won't ask, but for competitive exam you have to remember these points. Then in the same problem, why? Because here first condition is only satisfying, right? So highest order maxima also I explained by considering the first condition only, right? D sin theta is equals to n lambda. Now I can able to find the total number of bright fringe and total number of dark fringe in this problem. Okay. That is in the same problem, here it is for obeying only first condition. So last I explained the concept that is also based on the first condition. Now I can able to find the total number of bright and dark fringes. For n maxima, bright fringes, formula d by lambda. For n minimas, that is nth order dark fringe, that is d by lambda plus 1 by 2. So d by lambda, d is 1 millimeter, lambda is half millimeter. So then you will get the number of fringes is 2. Maximum number of bright fringes is 2. And n minima, here you will get d by lambda 2 means plus 1.5, you will get 2.5, right? So 2.5 means you have to see the option and here integer you have to take. For example, I will take as 2. So n maximum is 2, n minimum is 2. What is the total number of maximas and minimas? Total number of maxima or bright fringe. Total number of maximas or bright fringe. Then 2 into 2, n max is 2, 4 plus 1. How many total number of bright fringe will form in this problem? Totally 5 bright fringe will form. And then total number of minimas. Here how many total number of minimas will form? That formula is 2n minima only, right? That is I consider it 2, then it will form 4 dark fringes. In this way you have to solve the problems. I hope you understood this concept. And next concept is displacement of fringes in interference. Displacement of fringes in interference. So let us consider again two slits, S1 and here this slit is S2, and here there is a screen. From the S1 the wave will travel distance S1p, and from S2 also the wave will travel the distance, that distance let us take it as S2p, and this distance is distance between two slits, small d. This distance is distance between slits and the screen, that is capital D. Then you came to know that this is delta x, this value is d sin theta, we came to know, right? And this is the perpendicular bisector, like that you consider. This is the midpoint of the screen, and if we consider these angles theta after obeying two conditions means small d lesser than capital D, x lesser than capital D, then all the angles we can consider it as same theta and also small. In that case, this angle theta, this angle is perpendicular, then this angle becomes 90 minus theta, means you came to know that this angle also will comes to theta angle. Then you came to know delta x value is d sin theta. So two conditions also satisfied, means d sin theta is nearly equals to d tan theta. Here what is meant by displacement of fringes in interference? Okay, so in this case these waves are traveling in air medium. We came to know the path difference delta x is equals to s2p minus s1p, and that value also we came to know that xd divided by capital D after obeying two approximations. Then in any one of the path you place a glass slab. This glass slab thickness is mu, refractive index is mu and thickness is t. So because of introducing this glass slab, what happens means here the wave has to travel some distance in other medium, so the speed will decreases in this glass medium. Because of the delay, that means to reach point P it will take some extra time. Hence, before glass slab the fringe has to form here, right? Because now the glass slab is introduced, due to the delay that fringes will shift, it will move upwards some distance, that is called displacement in the shift. So some distance the fringe will move upward, means definitely some other fringe will occupy this place. Similarly, this fringe is shifting upward, means the central maxima fringe also will shift upwards. For that distance, how much distance the fringes are shifting upwards, the distance we will calculate. That is called the displacement of fringes in interference. That shift is happening due to introducing the glass slab in the path of the beam or this wave. If we introduce the glass slab for above wave, the shift will be upwards. Or if you introduce the glass slab for below wave or beam, the shift will be downwards. We will see that expression here. This is what before introducing glass slab. Then after introducing glass slab, the new path difference that I will write here. So old path difference is delta x. When there is no glass slab, the new path difference I will consider delta x dash. This equals, for this wave I will write S2P, entirely it is travelling in air medium, S2P minus, okay, but for the above wave it is not completely travelling in air medium. How much distance it is travelling in air medium means, definitely you can write S1P minus T distance. S1P minus T distance, it will travel in air medium. But what we have to neglect this distance, the distance travelled in glass medium, we cannot neglect. We have to convert the distance travelled in glass medium into distance travelled in air medium. Means we have to find equivalent air distance. Equivalent air distance means in ray optics also I explained in refraction, x distance the light will travel in glass medium or other medium, means in air medium how much distance it will travel, mu x distance it will travel, that is called optical path. Here also t distance the light is traveling in glass medium means, so its equivalent air distance become mu t, so that value we have to write. Okay, so before S1p is the path difference before introducing glass slab. After introducing the glass slab, the path difference become S2p minus S1p minus t. This is the distance travelled in air medium and this is equivalent air distance, that is mu t. This distance also we have to convert in terms of air medium. Then delta x dash is equals to new path difference S2p minus, here you can see S1p plus t of mu minus 1 you can write. Then the path difference delta x dash is equals to S2p minus S1p minus t of mu minus 1. Right. So for central maxima what is the path difference? That is delta x is equals to n lambda. This is the condition for bright fringes, right? N value is 0 for central bright fringe, means the path difference is 0. For central bright fringe the path difference is 0, hence this path difference if I consider it as 0, S2p minus S1p minus t of mu minus 1 I will get. Then this S2p minus S1p is what? S2p minus S1p value is xd by d. Then I can able to write here xd divided by capital D. This is S2p minus S1p value, t of mu minus 1. The equation become like this. And what is the value of x? X value is equals to t of mu minus 1 into capital D divided by small d. Then x is equals to, here this is the final expression. If you want means you can multiply and divide it by lambda. Then lambda capital D by d is beta. T into mu minus 1 beta by lambda. So remember this formula. What indicates this x value? So the fringes will shift upwards. Like that the central fringe will also shift upwards. How much distance it is shifted? Means it is shifted from the central maxima x distance. What is that value? That value is t of mu minus 1 into beta by lambda. This is the meaning of x. So I hope you understood the displacement of fringes in interference pattern, and based on this concept only, now listen. Write as a note. So this is the condition, 2 slits. Here there is a screen, this is point P. So here you are placing the slabs on the 2 beams. This thickness is T1, refractive index is mu1, this thickness is T2 and refractive index is mu2. In this case, what is the shift? How to get the shift formula means, we will find the net shift. Okay, net shift means due to the slab for upper beam the shift will be upwards, due to the slab for lower beam the shift will be downwards. Then the net shift formula is upward shift difference downward shift. Okay, like this we have to find out upward shift difference. We have to see which value is greater, then we have to subtract. And then for no shift after placing the two slabs, there is no shift in the fringes, then here upward shift is equals to, we can write downward shift. Then the formula for upward shift is, for upward shift thickness is T1, mu minus 1, mu 1 minus 1, beta by lambda is equals to, beta by lambda is same, is equals to T2 of mu 2 minus 1 beta by lambda. Then beta by lambda will get cancelled. Then now can we write the formula for no shift condition means the ratio of T1 by T2 is equals to mu 2 minus 1 divided by mu 1 minus 1. Remember this formula for no shift. So in the next class also I'll explain the concept which are useful for competitive exams. Then after we'll solve some more problems useful for PUC. Okay, thank you.